Thank you to Elektor magazine for helping make today's video a possibility, and all you viewers at home, please stay tuned to the end for a very special announcement. When I was a child, I often witnessed my father messing around with computers, components and soldering irons. One of my early memories is waiting impatiently for my father to solder on a connector to the AMX mouse that was going to eventually be connected to my BBC Micro. That instilled an interest in electronics in me, but it wasn't until adulthood that I really started to try to learn a little bit more about electronics. So throughout that early period, I would dip in and out of electronics just as something would take my interest. So for example, I would be interested in CB radio for a while, or I'd be interested in LED circuits or trying to make a light sensor. And a lot of that early research was based on what I could pick up from Tandy inside those small engineering notebooks. Also at the time was a magazine available called Elektor, and most of you are aware of Elektor because it's actually approaching a significant anniversary. That's right, Elektor is 6 decades old. Can you believe it? Something that's been around for so long. Started as a magazine, continues to be a magazine and online presence today. And the thing that I always liked about Elektor growing up was that it had really interesting projects in it at loads of different levels. So it was beginner levels and then advanced stuff. So you might get something about how to program a PIC microcontroller in one edition, and then that would lead all the way up to how to deal with some FPGA circuit. And that really suited my way of dipping in and out of electronics as my whims took me. So over the years I would pick up copies of Elektor and work on several projects, put them aside, come back to them. The nice thing about it was though that you always had support in that each project in the magazine. It would have a schematic, a description of how it functioned, normally a troubleshooting guide. There's all sorts of bits and pieces and resources to help you get going. I'll quickly show you some of these projects. The first one is a PIC microcontroller circuit. I can't remember what this is doing, but I believe looking at it that we have 2 power transistors here and basically a PIC and power regulation. And clearly this was driving some sort of industrial machinery or automotive, probably automotive injectors. I remember being in university, and if I'm not mistaken, Big Clive had a website then, and I used to look at his Jewel Thief project. I'm sure it's the same chap. Around that period I was getting interested in electronics, and I had this. This is of course a Game Boy. It was swap for a Casio TV. AJ, if you're watching, if you remember this Game Boy, I still have it. But more importantly, Elektor did an article about this, which, ignore the cartridge, this is actually an oscilloscope for a Nintendo Game Boy. So that was really groovy because I didn't have a scope at the time. More recently, you might have seen the video on this. In fact, you might have seen the video on all of those items. This is the Elektor laser time writer. And what this did, this had a laser fitted here, and it would actually write on this piece of photoluminescent paper, and it ran on an Arduino of all things. So it's very easy to learn how to program it and work this thing. So you can see the quality of the Elektor kits though is really high, and I think that's what separates a lot of the cheaper kits from the dearer kit. So you know that we were discussing software-defined radio in some previous videos. Elektor have sent me a software-defined radio kit. I think it's time we just open it up and have a look straight in there and see what we can do with it. First off, before we begin, Elektor kindly sent me some nice gadgets, including a really cool webcam cover for your laptop, an RFID credit card wallet, bottle opener, post-it notes, and of course the very useful resistor color charts, and of course an Arduino, because you will need an Arduino to go with your kit. I already have many Arduinos, so this and all the swag will be going to a lucky winner. Just please leave your name down below and say, swag, swag, I want swag. Now, this is the Elektor SDR Hands-on Kit as it arrives in a lovely, lovely box like that. And it says contents: SDR Hands-on Book, the SDR Shield, which is this item here, a ferrite ring core, a 2-hole ferrite core, and a RG178 coaxial cable. So all of those bits are required to make an antenna. Now I have to admit, I have had a peeky peek in this box because I did, of course, want to have a look through the book itself. And I'm just taking out the parts here, so that I'd have some idea of what this was all about. Now, those SDR radios that you buy on eBay and Amazon, the usual things, they're a self-contained USB pen drive. This, of course, is more a hat which goes on an Arduino. And the thing that makes this kit, though, really useful is this book. So a lot of you have been asking me on the last SDR videos that you want to get involved in it, you want to make a start on it. However, it's just so daunting. Once you start getting into the software side, you're really starting to get lost. And I was too, I have to admit. And we're only really using those dongles in a very basic configuration. So at a very high level, a software-defined radio requires some sort of receiving hardware, which is what you have in this kit. And then you require a processing element that runs on your computer that takes those signals and puts them through like a virtualized radio equipment almost. You know, it's almost emulating the various processes and stages that a normal communications radio would have to be able to decode the various types of radio. So on the most highest level, the softwares that people tend to be using is a software called SDR Sharp, and conveniently this book covers all of that, and you can see this picture. And SDR Sharp emulates a communication receiver, so it does AM, FM, all the different sort of bands like that. But just the reason I'm making the distinction, you have to remember that DVB, DAB, all of those other formats, Tetra, those are also other communications that are covered under radio, but that won't necessarily be decodable by the SDR Sharp type software. So software-defined radio is this broad thing. Now also, of course, software-defined radio can transmit. And if I'm not mistaken from what I've read, you may be able to actually use this as a transmitter. Now, in terms of the frequency range, this equipment goes up from, I think, 0 to 30 megahertz, which is pretty low, considering you could get these SDRs up to 3 gigahertz. But really, this covers all those interesting bands. So this is the long wave, medium wave, short wave bands, and some of the low ham bands. They're the areas which you're going to want to play, because of course shortwave radio travels thousands of miles around the world, so you might be able to pick up some really interesting things. Now the book is actually quite excellent. It taught me a lot, I have to admit. It covers the subject in reasonable enough detail that you're going to pick it up. So you're going to start here from just a simple block diagram of what's happening. And I didn't realize this, that these hardware, that basically is running a PLL. So it's kind of just an analog process at a large part. And what it does, it puts out of the headphone jack here, it goes into the sound card of your PC, where your PC will decode that. So the PC is actually using its hardware, the 16-bit DAC, ADC in its sound card to decode that. And you have here the actual circuit diagram of the hat module. So what you can do, even though it's using an Arduino right now, the reason it's using the Arduino is because conveniently it has a power supply, the USB serial interface for control, because you'll be using that to actually control the chip, telling the chip what frequency range you're interested in. But what it does mean is that in the future you could design your own software-defined radio hardware, which I suspect many of those dongles we see on the market are. It covers in pretty good detail the whole subject, and it goes right into antennas. It even covers the Arduino code here. It's actually really quite fantastic. There are a number of areas here where if you follow this guide, you'll be able to not only understand the subject, but even build test equipment, measurement equipment, and be able to use this in all these in various future projects. So for example, if you're familiar with Arduino, you can actually put a TFT screen on there and potentially just make your own radio, pocket radio with one of these. So that's pretty fantastic. So I'm just going to cover the basics there in terms of just construction. It does look like it does have some construction. I should really go through the instructions, but I don't think I need to. I mean, we can look at the picture here. It clearly just will go on like that. So we'll just solder those pin headers. And that's really almost the entire amount of effort you're going to have to put into the construction here. So it's a pre-assembled kit with SMD components. So I'm just struggling to align those. I went quite there just to focus on the alignment of those pins. And I have to admit, I'm not an analog guy, I'm not a radio guy, so I'll have to do my learning on this. Look at that. And he's done it wrong. So do not make that mistake. Just going to try soldering without any flux. Because I know you're sometimes like me, a little bit lazy with the flux, but that's absolutely fine. At the end of the day, these connectors are through hole and you can't really go very wrong. Don't put too much solder, I think that would be my only advice. Just because you know that you're going to have to push it into here, but it looks like the pins are really quite long. I've completed all the soldering, but I'm not going to chop the leads on mine just yet. I'm not quite sure what I'm going to be up to with it, and that really is still pretty neat. Let's take the time to have a quick look at this PCB. Okay, full disclosure, I do have the book open in front of me. I didn't want you to think that I'd suddenly become very competent in things. What we have here is the main IC, which is the SI531A, which supplies an oscillator signal at 4 times the receiving frequency of the divider, which is at IC2. And you have here a mixer, which is a 74HC4066 at IC3 position, which looks like that chap here. And then these are some op amps. So this is basically a filtration stage. This is the audio stage that comes out of the headset. And if you've got the book in front of you and go through it, that's what it says here. Again, the Arduino here, the way it's connected is actually to this chip here. And that is connected via the SCL and SDA. So you can see it's just connected digitally. And the Arduino is basically taking the serial data and it's using it to tell this chip what to do. So jumping ahead and 44 pages in, so you're getting quite far in here, you are starting to look into the area of antennas. And I'm just sort of studying here because, of course, in the kit you do have these pieces and they describe these different types of way of winding the antennas. So you could decide based on this what you want to build. I have on the side of my house recently fitted a large disc cone antenna. Oh, I tell you what, this book is a danger. While flicking through looking at antennas, there's so much interesting stuff here that you just want to see. These are a section here on all of the digital receiving modes, and look, they're picking up the actual weather map satellite information on this thing. And decoding all of these different signals. So this one, for example, is Morse. I must stop getting distracted. Okay, one more, I promise. After this, no more distractions. There's even a section here on making it into a standalone receiver. And this is the Arduino programming code to show you how to tune it without a PC. Okay, to the best of my knowledge, studying the book, I've come to a conclusion that at the moment, antenna technology is a little bit above me. I'm going to have to work my way to it. However, I figured out, as I do have an antenna on the side of the house, I could actually hook up to it if I have a suitable connector. Currently it does have an F connector on it, and just so happened in my box of stuff, I have this reciprocal F connector socket. So I do need to figure out how to solder that there. So what I'm going to do, I think I'm just going to trim that, as this ground is actually common ground on the board. So let's see if we can make this fit. We should be able to go on like that, so we'll have to trim this a tiny amount, like that. So that will be good there. So I flipped it over onto the back, so you can see that is the ground pin and that's the antenna pin, and we're going to have to mount this like that. So I'm going to make a mark here and here, and you're probably saying, why are you fitting it on the back? Well, that's because the ground plane is actually only on the back, as it turns out. So you'll have a lot of trouble trying to solder on the other side because there's nothing to solder to. So I'm just going to take a small scratching tool. You probably have a scribe or something more suitable than this, and then I'm just going to scrape away that top level of varnish to expose the copper underneath. Unfortunately, we're quite far away from that antenna pin, so we don't really have to worry because the next one is all the way over here. But as a sanity check, I will just double check that. That looks absolutely spot on. So we'll just do the other one now. So you're effectively making your own solder pads. And once we're done with this, we're going to prepare them that we can make a nice solder joint. And how we're going to do that is really just tin them. If you have a little bit of flux, you can put a bit of flux on there now. That could help. In fact, I happen to have a fluxy brush here, so I'm just going to put a dab of flux there, dab of flux there. And why not a dab of flux on that antenna pin, because we're going to be soldering to that momentarily. Let's apply here. This is some lead-free solder. Again, I do sometimes have some issues with the lead-free, so I'm going to put the soldering iron up just a bit hotter, because this is a big old ground plane on this board and you've got a lot of heat getting dissipated into it. As you can see, it's not quite perfect, but we do have a nice blob. Let's do the other side there. If you have one of those wire wool, steel wool type brushes, you could brush down that copper first as well and you'll get a much better adhesion on it. So that's looking pretty good. I'm going to just wipe off the excess now. Again, it's getting very cool very quickly. Make sure your iron is nice and hot. I'm actually setting mine even higher now because, of course, there's a lot of metal work on this we're going to want to have to get through. And I'm just applying a bit of additional flux to these little legs here, because you can see that's a massive amount of metal work. It's just going to suck all the heat. So I really want to just do a tack. I'm going to go for this inner one here. I'm going to apply that heat to it and just get it tacked up as best as possible. And I'm aligning that center pin to make sure it's over that antenna pad. So far, so good. That looks okay. So I'm going to go to the other side now. We've made our tack joint on that left-hand side, which means we can spend a lot more time on this right-hand side one and pump a lot more heat. So I've got my iron up nice and hot. See, I'm just holding it there now for a while. See, that's a nice firm solder joint. And while we're at it, let's do the antenna pad. Fortunately, that was a lot easier to do. And then let's finalize that original ground pad. Now that our soldering iron is nice and hot, and we don't have to worry about the connector slipping all over the place. And you can really see how long I'm holding it on there for to get that to start melting that solder. Can be a bit ginger, but yes, that looks pretty good. It's quite nice because you could just cut off that little leg here and you still have access to those pins if you want to solder a pin header on it. The book shows that it actually has these pin headers on these various places because you might use them for test points and various other projects really that make use of those. The moment of truth, of course, does it still fit? Come on. Unfortunately, the answer is yes, and that's quite neat. Let's just hook that up to our computer. F connector for the aerial, audio to the sound card, and of course USB for data and for power. Hooking it up to the PC was a breeze. I already had an F connector and a USB. I believe it's a B connection, whatever it's called, the kind that your printer have and you don't really use them anymore. The Arduino was recognised straight away and registered itself as a COM port 5. I went onto the Elektor website and downloaded the package that accompanies this book, but actually you don't really need this right away. In fact, I would say if you're going to do this, download it, but just keep it handy. You're not going to need it for a while. So rather than go your own way, what I suggest is you look in the book at page 15 and follow the steps there, because it says getting started with G8 JCF SDR, and you'll just find that on the website g8jcf.uk and have a quick look through there. You'll find the download, just select the latest build, click that, and within a few moments it will be there. Locate the installer file you just downloaded, hit install, and let nature take its course. If you haven't already, it's a good idea to bring up Device Manager and just have a quick look at the COM port. In my case, it installed itself as COM port 5. When you first load the application, you'll need to go to the configuration menu and set up all the various options. These are clearly highlighted in the book, but effectively you're setting up to Elektor SDR. You want to select the right sound card that you've hooked up to, and you'll want to make sure the correct serial port's set. You might have to reload it at this point, but once you reload it, it'll work properly. In this attempt, I actually had it configured wrong. The radio sounds were actually coming to a speaker, which was then going into the application via the microphone, yet it was still decoding audible sound. And with a bit of luck, you'll start receiving some radio signals. And this is pretty much how it looks when you get everything set correctly. I can't actually receive this on my other SDR dongle, so I was actually quite impressed because this kit actually handles low frequencies really well, and it turns out there's a lot of stuff on the low frequencies. Who knew? If you can find a radio station in one of the BBC ones, for example, or something with a known frequency, you can actually calibrate this so that your display in the top right corner is accurate, so you can then find other channels based on what you can find on the internet. But this is a really good start. Once you get to this point, there's a whole lot more you can do, and you're going to be able to spend a lot of time learning and exploring this subject. I've worked my way through the book up to about page 20, I'd say. It's absolutely fantastic. The software that they recommend you try before anything, there's a first piece of software, and it's called G8JCF-SD, and that's a great piece of software because it installs the firmware onto the Arduino itself. So it knows the Arduino is connected, and it will install the sketch on there. So you don't have to install the Arduino IDE, load up the INO file, move the library. There's a library for the main chip that you have to move into the Arduino sketch and compile it and do all that. You don't need to do any of that with that particular application. And that will perform a lot of the software-defined communication radio functions like SDR Sharp. So you have your AM, FM. You don't have a waterfall, unfortunately, but that's fine. You can get that. You can get that because what you can do is later you can open up SDR Sharp, and there's pictures in the book showing you how to do this. And what you use, because SDR Sharp can't communicate directly with your little receiver board on the Arduino, you just load a separate application which communicates on that serial port, and you can move the tuning up and down. And there are actually calibration guides within the software itself. Once you work your way through this, you'll learn about digital communications. You'll be able to receive potentially from weather satellites. You can build equipment to test your reception and check things. That whole section that we just skimmed over earlier, I kind of avoided, was that on antenna design and building all these antennas. I mean, this is really a very good education into not just software-defined radio, but literally radio. I mean, this is the equivalent of those electronic kits you used to have, where you'd have a big fat book and a big components and all of the little spring terminals, and you used to do the wires. I think if you have really the interest of software-defined radio as a hobby, I don't think you can get much better than this. I honestly wish now that Elektor had contacted me before I made such a huge investment in, I say huge, SDR is actually a relatively cheap hobby, by the way, investment already in equipment, because I'd have a lot more fun with this, because effectively if you buy a SDR dongle and an antenna and you use SDR Sharp, great, you can tune it in and listen to channels, which is the equivalent of buying a communication receiver. But if you buy this, you are getting a hobby. You're getting a true hobby if you've got more of an electronics side to you, or software side to you, programming side to you, where you want to understand things and make things work. One of the things that was phenomenal, if you take that dongle and you actually unplug it and you just plug it into some speakers, you unplug it from the PC, plug it into some speakers, all you hear is like white noise, like that. And what was crazy, the application that I mentioned earlier that came with this, if you set it to listen to the microphone on your PC, I had my recording microphone, and I brought that sound near the speaker, near the microphone, it would decode it into audible sound. And I'm like, oh, my mind is blown. I thought that these SDR dongles were doing all of this amazing sophisticated thing. I didn't realize it was this control of phase lock loops, and they're so many degrees out from each other, and between all of those interactions you can extract all this amazing data. I'm going to have to really spend the next, however many months, I think, going through this book and really just playing with it. I'll post videos as I go along. When it shows you the circuit that you're going to build, it actually shows you the Arduino code that you'll need in there. And if you look in the folder on the software, it has a lot of these examples already structured. And I think they're in chapters. If you follow them, they're in actually chapters already. So you can get onto that. But look at this thing. Towards the end, you end up pretty much building your own transceiver, an actual transceiver. If you want to start at the beginning and have a destination at the end where you end up with a transceiver, okay, SDR Hands-on Kit. It's been really great to be able to explore my hobby and have my horizons broaden in a nice hold your hand kind of way from Elektor's kit. Elektor have been very kind in offering all viewers of this show a green digital membership for £9 instead of the usual £56, and that's for the whole year. If you'd wish to take part in that offer, all you have to do is go to the link on the screen and enter the code shown to receive that discount. I'll also put the description of how to do that down below. And what I'd really love would be for you to share your experiences with Elektor magazine in the comment box down below, and so we can really see if you had the same experience as I had growing up. Thank you for watching. Stay tuned for more videos about this in the future. I'm pretty sure I'm going to be revisiting this book. And as ever, thank you for watching.